Continuing on, how else can we violate the assumptions underlying the t-test? What if we insert an outlier, right? What if we insert an outlier? And that violates the assumption because this outlier makes this whole distribution non-normal, right? Now it's normal plus an outlier. The null hypothesis is still true. I'm showing these distributions with box plots now instead of with histograms so that I have room to show you the outlier. The variances are the same. Sample sizes are approximately the same. They're both normal except for that one point. That one outlier can really throw things off. Okay, so now my rejection rate is 0.02 instead of 0.05. This histogram is supposed to look uniform, and it doesn't. I've thrown everything off based on using just that one outlier. Even though I use this test that's supposed to be okay for unequal variances, which is what will look like is happening when I have this outlier here increasing the variance. What can I do about that? Well, what procedure do we know of that's robust to outliers? We have the rank sum. And here I've written down the rank sum with its normal approximation reference distribution. This is the mean and the variance that we'd get for the rank sum if we use the normal approximation for the reference. And now everything's fine. The rank sum works perfectly fine in the presence of outliers. No problem at all. So when you have an outlier, t-tests are going to be really sensitive. Don't leave your outliers in and then do t-tests. But the rank sum test is going to work perfectly fine because it won't be influenced by those outliers. Where do outliers come from? If you have an outlier, the first thing you should do is go see if it's a typo or a mistake, because sometimes you can get rid of it that way. Sometimes there's a mistake such as the wrong population. I'm trying to measure the heights of women and a man got in there. And so this person actually shouldn't be there and I can remove him. When you have outliers, you're looking for excuses to take them away, but you do need an excuse. You can't just decide to take it away. Or sometimes it's just a heavy tail. We're looking at how long people live until they die from a particular disease, and some people just live a really long time. In this last case, you can't throw them away, but doing something like taking the log of every value may help those values look a little bit less like outliers.